Hey guys, we are talking about multiplying and dividing with exponents today. Let's get started. Let's look at number 1. You may recognize this. This is called expanded form for exponents. So this number that you see multiplied by itself over and over, that's going to become the base, which is just to say like the normal looking number. So I'm going to go ahead and write it. It looks like it's a bunch of 5s, so I'm going to write a 5. Now, the number of times it's multiplied in repeated multiplication, the number of times is going to become the exponent. So let's count how many times it's there. 1, 2, 3, 4, 5, 6. All right, so it looks like 6 is going to be our exponent here. So this one is called 5 to the 6th power. Okay, so now over here we've got 12 as our main number, so let's make that our base. And how many times is that 12 used in repeated multiplication? Let's count. 1, 2, 3, 4. So our exponent is going to be 4. Okay, now we're not worrying about the instructions really quick. I know it does say to write it as a positive and as a negative exponent. We're going to come back to that in a second. We're not going to forget that. Let's just keep talking about exponents for a second right now. So we have this, we have that. Now what if we have, look here at number 6 with me. What if we have two numbers that are multiplied together and they both have exponents? Notice that the bases are the same. They do have to be the same for this to work. But how would we do this? Well, kind of the most basic way for us to think about this is for us to turn this into expanded form and then count the number of times it's used in repeated multiplication. So let's do that. So 4 to the 4th power, let's write it out. 1, 2, 3, 4. Okay, got it? And that's times 4 to the 3rd power. So we need 3 more 4s. 1, 2, 3. Okay, there we go. So now when we write this again as an exponent, what's our base going to be? It's still going to be 4. What will our exponent be this time? 1, 2, 3, 4, 5, 6, 7. So this time our exponent is 7. Can you see any maybe possible tricks that we could use to go from this straight to this without having to write all these numbers out? Can you think of how to maybe combine these two exponent numbers to get the 7? Let's see, 4 plus 3 equals 7, right? Maybe we could just add these exponents together. I wonder if that would always work. Let's look up here at this one. 6 times 6 cubed, 6 to the 3rd power. Now, quick note, whenever you see a number by itself and you want to think of it as an exponent, you can always write a 1 there, okay? If that's helpful, you can definitely do that, and it will be helpful sometimes for sure. So 6 to the 1st power, it's just going to be 1 6, right? Times, and this time it looks like it's 6 to the 3rd power, so we need 3 more 6s. 1, 2, 3. All right, now let's write it again as a single base with an exponent. So the base is still going to be 6, and the exponent we need to count 1, 2, 3, 4. The exponent is going to be a 4. Okay, now let's see if this idea we came up with down here of maybe adding the exponents together, let's see if it still works. So the exponents would be 1 plus 3 equals 4. Hey, it still works. Okay, let's try one kind of different looking one and then we'll know for sure. So this one has a negative exponent, and as we remember, negative exponents jump to the other side of the fraction bar and you make the exponent positive. Okay, let's do that. So first of all, we have just a regular 7. I'm going to write 7 times, and now we have 7 to the negative 1 power. So we have to jump it, because this is negative, we're going to have to jump that 7 to the other side of the fraction bar, and then we're going to make its exponent positive. Okay, so right now it's just a regular number. That means we need to put it under the fraction bar, and then we can make it a positive 1. Okay, so now we have 7 times 1 over 7. Let's do the math on that. We can kind of rearrange this. This 7 can be rewritten as a 7 over 1 times 1 over 7. Do I need to write the exponent of 1? 7 to the 1st power is just 7, so I'm going to leave it off. And that's going to equal 7 over 7. And 7 divided by 7 is going to equal 1. Okay. So it looks like the answer to this problem is 1. Now I don't mean the exponent is 1, I mean the actual answer is 1. So let's go back up here and see what's going on here. If we're going to use our trick of adding the exponents together, we definitely need to put an exponent here, and that exponent would be 1. Whenever there is no exponent, you can add an exponent of 1, and that would be correct. So now let's add these exponents together. So you have 1 plus Negative 1 equals, well, let's see, same signs add and keep, different signs subtract. So we need to subtract these. It's going to be 0. So this gives us the new exponent right here. So let's write it with the same base and the new exponent of 0. Now, what does 7 to the 0 power equal? If we need a little review from yesterday, anything to the 0 power will always equal 1. Okay, so 7 to the 0 power equals 1, which is the same thing as we got here. So it looks like no matter what you're dealing with, whether it's positive or negative exponents, the rule of adding the exponents together will work. And here's that rule right here. When you're multiplying with exponents, keep the base the same and add the exponents together. In fact, if you want to come full circle, take a look at problems numbers 1 and 2, where we had expanded form. What would happen if I added an exponent to each of these 5s? I know I was just telling you if there's no exponent, you can always put a 1 there, right? Okay, what if we're going to use our rule of adding up the exponents? Let's see, 1, 2, 3, 4, 5, 6. Ha! It even works for that one, 5 to the 6th power. Okay, so now I've ignored this instruction of putting a negative exponent for long enough. Let's go ahead and add some negative exponents to these. Let's review our rule first. Negative exponents means you're going to jump to the other side of the fraction bar, and then you'll make that exponent positive. Okay, let's do that on the ones we've answered so far. So for 5 to the 6th power, I'm just going to write an or, and then I'm going to jump that 5 to the other side of the fraction bar. Right now there isn't even a fraction bar, but if there isn't one, you know it's like that, right? So we need to jump that 5 under the fraction bar and make its exponent negative. So it's going to be that. You don't have to put this one there. I was just kind of illustrating. Of course, if you did put it, that would be fine. Okay, now let's do the 12. What's the 12 going to do? It's going to jump below like that. And then what about that 4? We're going to keep it as a 4, except we're going to make it negative. Good. Okay, what about this 6 to the 4th power? All right, we're going to put it under the 1. We're going to jump it to the other side of the fraction bar. Keep the 6 like it is. Take the 4 and make it negative. All right, cruising along. What about 4 to the 7th power? Let's jump it to the other side of the fraction bar and take its exponent of 7 and make it negative. Okay, awesome. Now 7 to the 0 power, it's just going to equal 1. You should put 1 for your answer there. That's the best answer. If you did try to jump it to the other side of the fraction bar and make the exponent negative, well, you can't have a negative 0. So yeah, you're just going to go with 1 there. You could give this version of the answer, or you could give a 1. Okay, let's go on to number 10. All right, so we haven't solved this one yet. We could write it all out with 11 squared, 11 times 11, times, and then we would put 4 of these guys. This is starting to be a lot of writing. And then we would put 3 of these guys. And then we would multiply it all out, or we could just say, no, we don't want to do all that, and we could do 2 minus 4 minus 3. That's the exponents. So basically when I said minus 4, it's plus a negative 4 because we're adding the exponents, right? But when you say this, that is the same thing as just subtracting them because same signs add and keep, different signs subtract. So 2 minus 4 is negative 2. Negative 2 minus 3 is negative 5. So is this my answer? No, it's not my answer. It's just my new exponent. So don't forget to keep that original base, which is 11, and then put the new exponent on it. So the new exponent is negative 5. All right, good. Now are we done? Almost done. Remember, we're supposed to write it as a positive and as a negative. So let's do that. It's currently as a negative, so in order to make it positive, you're going to jump it to the other side of the fraction bar, and then you're going to change the sign on that exponent. So it was negative, we're going to make it positive. Okay, and that's your answer there. Let's try number 12, and then we'll be done with this page. Okay, so 6 to the negative 2 times 6 to the negative 5 times 6 to the negative 1. So you could write it all out, or you could just add the exponents. So you have negative 2 plus a negative 5 is the same thing as minus 5. I'm just going to write it that way. Plus a negative 1 is the same thing as minus 1. And now let's do the math on that. Now they're all the same signs, so I'm going to add them all up and then keep the negative sign. And if you would like to use your calculator and just enter those negatives carefully with it, totally, go for it. So negative 2 minus 5 is negative 7, and minus another 1 is a negative 8. So is this my final answer? No, this is my exponent, but we still need to write the base. The base is the same as it was up here. So the base is a 6, and the exponent is a negative 8. So there's the first half of my answer. Now let's write it with the positive exponent. So we're going to jump that 6 to the other side of the fraction bar. And we're going to take its exponent and make it positive. We're going to change the sign on the exponent. And then we're done. Okay, so that is how you multiply with exponents. Just keep in mind this only works if the base is the same. And I also want to do one more problem I almost forgot with the zeros. Okay, so now with the zeros, you know that anything to the 0 power equals 1. So there's a couple different ways of looking at this. You could go ahead and say 4 to the 0, I'm going to just recopy this problem. 4 squared times, well 4 to the 0, that just equals 1, so I'm just going to put a 1. Times another 4 to the 0, that equals 1. Okay, so 4 squared times 1 is just going to equal 4 squared. You can think of it that way. That's great. Or you could look at it and say, hey, look, all these bases are the same. They're all 4s. I'm just going to add the exponents because I know when they're multiplied together, we just add the exponents. So you would have 2 plus 0 for the exponents. And that would give you a final exponent of 2. And then you're just going to put that exponent of 2 back onto the base of 4. You get 4 squared. Here's what I don't want you to do. I don't want you to think, okay, 4 to the 0 power is 1, so I'm just going to rewrite this as this. Okay, what's wrong with this? You're thinking 4 to the 0 power is 1, but you're writing it as 4 to the first power, which is something different. So don't do it like this. You can rewrite it like this, or you can just add the exponents like that, but don't make a 4 to the 0 power into a 4 to the first power. Okay? Awesome. So that is your multiplying with exponents. Now, here's your assignment. You're going to do just the evens. Make sure you keep it in exponent form unless your final answer is just like some number to the 0 power. In other words, it equals 1, like we did here in number 8. In this case, you can leave it as 1 or as a to the 0 power. But in all the other cases, you should be leaving it as an exponent. And be sure to do the positive and the negative exponents, okay? All right, so now you ready to do some dividing? Let's do this. Okay, so we're going to expand it out kind of like we did with multiplication, and we're going to see if we can find some patterns. So let's take this guy right here. Let's put him in expanded form. So 2 to the 4th power is going to be 2. We're going to use that 2 4 times in repeated multiplication. And then on the bottom, 2 times. Okay, so did you guys learn how to cancel these things out in division problems? Have you done that before? Basically, the 2 divided by 2 equals 1, and 2 divided by 2 equals 1. So we've just turned those into 1s, and 1 times anything else, anything times 1 is just itself. That's the multiplicative identity property, right? So we don't really need that because it doesn't change what's up there. Now on the bottom, we can't let the bottom just be empty. That's not good. So we do want to put a 1 there. Anytime you're canceling out and you find that leaves either the top or the bottom to be empty, make sure you put a 1 in there. Okay, so this is going to be 2. So it looks like we've got some expanded form here that we need to put as an exponent. So we have a 2 for a base, and how many times is it used? Twice. So this would be 2 to the 2nd power. You could put it over 1, but you don't really need that. It doesn't change anything. And then the or would be 1 over 2 to the negative 2 power. Okay, so going back to trying to find a rule. Here are the two exponents. You have 4 and you have a 2, and we're looking for a 2. So 4 and then some operation 2 equals 2. Well, in multiplication, we added the exponents together. Do you think maybe in division we should do the opposite? Should we subtract? Let's see, 4 minus 2 does equal 2. So that works. Let's see if it works on the next one. So we have 13 to the negative 4 power over 13 squared. So what I'm going to do, this is a negative exponent. I'm just going to pop all those 13s down to the bottom and make them positive exponent to expand it, okay? So I'm going to put 1 over, because when this pops down to the bottom, there's going to be nothing else there. So I got to put a 1 there. And now I have 4 of the 13s. 1, 2, 3, 4. And then I have 2 more of the 13s from this guy. 1, 2. Okay, so now I have 1 over all these 13s. Let's make that into an exponent. So I'm going to still have 1 over, and then I'm going to put 13 as my base. Now we have to count these up. 1, 2, 3, 4, 5, 6. 1 over 13 to the 6th. Or, okay, so for this version, we're going to pop that 13 to the top and change the sign on the exponent. So it's going to become 13 to the negative 6th power. Okay, so let's think about our rule that we kind of came up with, but we weren't sure about here, where we subtract our exponents to find the new exponent. Okay, let's try that. So we take our exponents. Negative 4 minus 2 is going to equal negative 6. And is that what we got here? It sure is. So you're just going to keep the base the same. You're going to you're going to subtract the exponents together, and this guy is going to become your new exponent. So you'll rewrite the base, and you're going to put the new exponent on it. And that's how that's going to work. Let's try a few more problems, okay? So 4 squared over 4 squared. So let's take those exponents and subtract them because we're dividing here, right? We've got this fraction looking thing, which means we're dividing. So those exponents are 2 and 2. So we're going to subtract them. We're going to get 0. So that means the base is still 4. That doesn't change. Our new exponent is going to be 0, which is the same thing as what? Anything to the 0 power is equal to 1. Good. Let's just expand it out and make sure that looks right. So 4 squared over 4 squared. These will all cancel. You're left with 1 over 1, which equals 1. Yeah, it totally checks out. So your answer here would be this. You don't have to worry about the positive negative exponent when the exponent is 0. Let's go on to number 8. Okay, so this time we're just going to use our rule. So we have 7 to the negative 1 over 7 to the negative 2. So let's do negative 1, this guy, minus this guy, negative 2. Notice I have 2 negative signs there. Don't forget it doubles up because you're already subtracting your exponents. And if you're subtracting a negative, then you're going to have those 2 negative signs there. Now when you have 2 negatives in a row, it becomes a positive. So it's going to be like this. And negative 1 plus 2 is going to equal 1. And if you feel more comfortable putting all this in your calculator, then do it. Totally fine. Negative 1 minus a negative 2 in your calculator should give you a 1. So your final answer here is going to be 7 to the 1st power, or 1 over 7 to the negative 1st power. All right, let's do a couple more examples. Okay, 15 to the 0 over 15 to the 3rd power. So we're going to do 0 minus 3. We're taking the exponents and we're subtracting them. And that's going to be negative 3. Now, is this my final answer? No, that's just the exponent that I'm going to put on the base. And the base here was 15. So let's add this new exponent to it. We'll put it right there. And then we're going to do or 1 over. We're jumping him to the other side of the fraction bar and making his exponent, we're changing the sign on the exponent. We're making it positive. So 1 over 15 cubed. What if we did it a different way? What if we took this 15 and said, oh, anything to the 0 power equals 1. So we just made it 1 over 15 cubed. That works too. And then you would have to change it around and say this. But just like I was saying in the multiplication side, whatever you do, don't take this guy and say, oh, that's the same, a 0 is the same thing as a 1, so I'm going to make that 1 into the exponent. Because that's not going to work. 15 to the 0 power is not the same thing as 15 to the 1, so don't do it that way. All right, so one more example. Looks like we've got a couple negative exponents here, and we're just going to take them and subtract them. So we're going to have negative 2 minus whatever's down here, which is negative 4. So it looks like we doubled up our negatives again. So we're going to have negative 2. Those 2 negatives in a row become a positive, and then make that a 4. Well, it already was a 4. Negative 2 plus 4 equals 2. So this guy is going to be our new exponent. Let's just go ahead and rewrite what was the base, which was 4. And then we're going to put that exponent on it. And then we just have to write the negative version. So pop him to the other side of the fraction bar, make that exponent negative, and you've got it. Just like with your multiplication assignment, here you're going to be doing just the evens. This is your assignment page. I circled this one. I just wanted to make sure I remembered to tell you that when the base doesn't have an exponent on it, what should you put there? Yes, you should put a 1. And then you can use your exponent rules of subtracting. Oh, and I never gave you your rule. Here we go. When you're dividing with exponents, keep the base and subtract the exponents. Okay, hope that was helpful. If you have any questions, let us know. We love to hear from you. Thanks, bye.